So today's topic will be divided into four segments. I would like to talk about major trends of flexible display first, and next we will consider about the prerequisite issues for flexible display development. And as a third items, I will briefly talk about OTFT status, and to realize the OTFT, I will talk about a brief story about printing technology. And then I will summarize this topic. Next slide, please. There are two big trends in flexible display fabrications. The first item will be the high-performance display fabrication by using an existing TFT technology such as LTPS or amorphous silicon TFT. Especially in case of this approach, many people are using the metal foil as a substrate, because the thermal stability of metal foil is best for the flexible substrate. So from this approach, we can make the ultra thin light display with a limited flexibility and great durability. We can also give a rugged and conformable display like this. However, stainless steel is not an ideal flexible substrate, as you know well. So next slide, please. So more people are focusing on fabrication of plastic electronics. However, plastic devices are much more difficult to process. So many research groups are focusing on OTFT technology. Next slide, please. But for making plastic devices, there remain a number of significant issues before flexible display become commonplace. For example, suitable substrate should be selected, and we should develop the encapsulation technique for the plastic substrate. And then coating and interface integrity and repetitive flexing should be considered. From this basis, we should select also the TFT technology. After that, we should increase the yield and reduce the cost. In addition to these items, we should also consider about the killer application if we want to make the flexible display as a mainstream. Next slide, please. Okay, so let's start with the substrate issue first. There are three types of candidates for the flexible substrate. The first one might be the metal foil, and the second one is plastic substrate, and the third one could be a very thin glass with a polymer coating layer to enhance or reinforce the brittle properties of glass. Next slide, please. One more, please. So in terms of maximum process temperature, stainless steel is best candidates. But in case of metal foil, the planarization is very difficult, and its high conductivity is also problematic for the electronics purpose. So what about the plastic substrate? In case of maximum process temperature, the choice of plastic substrate is the worst. So we cannot use the existing TFT technology on this kind of substrate. And in addition to that, in case of oxygen, water, permeability, it is worst. So there are many issues to be solved before we use the plastic substrate, especially for use of AMOLED. Next slide, please. Nevertheless, many research groups are developing the encapsulation technique of a plastic substrate like this. The refrigerative technique will be the multi-stacking of the organic and inorganic layer to retard or delay the transmittance of the water and oxygen through the OLED active layers. But in most cases, the current status of barrier technology is not that perfect. In case of water vapor transmittance rate, the current status is about 10 to the minus 4 gram per square meter per day, but the target requirement must be 10 to the minus 6. So we should develop a lot about encapsulation technique. Next slide, please. But if we obtain the very good plastic film with a certain barrier films, we can think about the TFT technology on it. So in terms of flexible TFT fabrication, the maximum process temperature is most important issue. So if you see this table, you can easily find that the OTFT can be a most plausible technique for the fabrication of the flexible switching device. But next slide, please. But if you make the OTFT device by using lots of photolithography method, there are too many failure modes during process of multiple procedure of stacking. So, for example, there are shrinkage and bending, strain and delamination and crack, film filling, and long-term fatigue. This kind of phenomenon can be occurred during process. So it is almost impossible to do a perfect alignment of each layers during multi-stacking, but we should change a certain photolithography method to printing. Then we can make a good alignment. Next slide, please. So many people often want to change the batch type process to the continuous roll-through process, but from common photolithography, we cannot realize this kind of roll-through process. So every procedure should change it to the printing or spin coating method, not spinless coating method. And then from this change, we can save lots of cost. So if you see this table, you can find that the lots of cost will reduce if you change the Gen 5 glass to 48-inch plastic roll-through process. Next slide, please. Okay, so assuming that all kinds of technology aforementioned will be developed, let's start with the OTFT status. There are huge numbers of papers relating to OTFT fabrication, but especially from year 2004, you could find lots of prototype samples in a paper or journal. But in the year 2004, many companies only made OTFT array on glass substrate. But from last year, Polymer Vision or Flash Logic successfully prepared the fully rollable plastic devices like this. So Samsung SDI is also developing the many types of printing technology. So the representative printing method will be the inkjet printing, but we are also focusing on fabrication of subtractive patterning by using laser ablation technique. Next slide, please. So this is an example of inkjet printed OTFT device. So if you see the next figure, this is the organic semiconductor line fabricated by inkjet printing method. And then after that, we just spin coat the gate insulator on it, and then we print metal line like this. So the line width of gate metal line could be 36 microns. Nowadays, we are performing 30 microns. Next slide, please. From this structure of device, we obtained the mobility about 1.3, and the stability was also very good, except VTH variation. From this reason, we are mainly focusing on interface control and change the fabrication materials. Next slide, please. But even though we can obtain the very good properties of a TFT device, we should more consider about the alignment problems, because if we want to make a roll-through process, the substrate will simultaneously move with the printing position. So in most cases, it is really difficult to realize the perfect alignment. To overcome these kind of problems, there are some solutions. So we can increase the size of TFT components like this, but from this strategy, the increased plastic cap will be act as a disadvantage. So in most cases, the fundamental solution will be development of the self-aligned patterning method. Next slide, please. So as a self-aligned patterning method, we developed laser-assisted patterning method like this. So the key point is the wettability control of the channel area in this case. So in other words, we eliminated the cytopolymers, which is fully fluorinated and repellent to all kinds of solution. Then we just spin cast the organic semiconductor to cover the channel area like this. So this profile show you the group after the laser assisted liftoff. Next slide, please. But in case of cyto, it cannot absorb any UV light, especially 248 nanometers. So we insert other layer which can absorb the UV light very rapidly. And then if you do a laser ablation from top, it will thermally activate this layer, and then it diffuses into the cyto layer, and then lift-off process can be occurred. From this procedure, we successfully obtained the patterned image like this, and then we obtained the relatively good off-current behavior on our devices. Next slide, please. So as a summary, there are two big trends in a flexible display development, and there are too many prerequisite issues before the flexible display become commonplace. And I explained about the brief status about SDI printing technology and self-aligned patterning technology. Thank you for your attention.